Hi everybody. Since I can't be in class this morning, I wanted to give you a little video to kind of give you a preview of the practice that you'll be working on for the rest of the class period. So what you're going to be doing today is very similar to what you did in the video. So you're going to be modeling word problems using linear equations. Now, in addition to writing the equation, what you're going to be doing in today's practice is actually going back to those other representations that we've used before. So you'll be making a table, making a graph, writing a function, and then answering some questions. So again, some of this will be very similar to what you did in the video, and then some will be going back to those other representations. So I wanted to go through one with you first, and then you'll be trying a couple in your own as you go through the class period. So let's go ahead. The notes I'm taking here are in page 5 of your packet. So go ahead and find page 5, and then we'll get going. Okay, so here's our word problem. So it says a small pool holds 1,500 gallons of water. When there were 5 gallons in the pool, I turned on the hose to let it fill up the rest of the way. I checked the flow on the hose and found that it was filling the pool at a rate of 2 gallons per minute. So if you think about what's going on here, sometimes I like to sketch a picture to kind of help me think through it. So I've got my pool. There's my very fancy pool, right? And right now, there's only 5 gallons of water in the pool. So it's pretty shallow right now. And I'm using a hose to let it fill up the rest of the way. So let's work through this problem here. So the first thing, it's asking us to make a table using numbers. So I'm going to go ahead and make my XY table here. Now, I know that when they started here, right, there were 5 gallons in the pool. So I'm going to make a note to myself. This is my starting amount. So since this is the start and no time has passed yet, I'm going to put 0 in my X and my Y is 5. So I'm going to actually write this. My X we know is in minutes, and my Y is measuring the number of gallons. So when no time has passed, I'm starting off with 5 gallons in the pool. Now, it's telling me here, let's see, that the pool is filling at a rate of 2 gallons per minute. So each minute I'm adding on 2 gallons. So that would tell me then when 1 minute has passed, now there's a total of 7 gallons in the pool. When 2 minutes have passed, there's a total of 9. And again, because each minute that goes by, I'm adding 2 gallons. So we could keep adding up or adding values to this table, but this will give us a sufficient number to get started here. So now let's go ahead and make a graph to illustrate what's happening here. So on my x-axis, right, I'm going to put the number of minutes. And on my y-axis, we're going to write the number of gallons in the pool. Okay, and I'm just going to count by ones here. 6, 7, 8, 9. I'm just counting by ones. Okay, so looking at our table, I don't know if I can fit both in the window here. Probably not. So at time 0, we know we have 5 gallons in the pool. At time 1, we know we had added 2 gallons, so we are at 7. And at time 2, we had 9 gallons. So I'm going to go ahead and use my ID to make a straight line through these points. Okay, and we could see that going on until the pool is filled. Now, the next part here is asking us to describe our function using an algebraic expression. So I want to look at this a couple of ways. First, let's think about how we did this in the video. We know, and actually I'm going to say we're going to use an equation here. Since that's what we are writing, our linear models are looking like equations. So we said in the video, we know by looking at the graph, this is modeled by a line. So the form we've been using to represent lines is our slope-intercept form. Y equals mx plus b. Now, when we talked in the video, we said our m is going to be represented by the part in the problem that repeats. And our b was our starting amount. So if I go back to the word problem, the part that's repeating every minute is the number of gallons. For every minute that goes by, I add 2 more gallons to the pool. So I'm going to replace my m in my equation with the 2. So I'm going to put that here in green to match that. So we have 2x plus, now our starting amount, right, we made a note of up here, we started with 5 gallons in the pool. So that's going to be our b value. So y equals 2x plus 5. Now, I always, when I have an equation, well, let's do this first actually. Let's see if this makes sense with our graph. So we wrote this using the word problem. Let's go back to the graph. We know the positive 5 should be the y-intercept. And if I go back to the graph, I can see that I have a y-intercept of 5. Right? So graphically, we know the b is the y-intercept, and we know the m is the slope. So our m is 2, which is just 2 over 1, and looking graphically, I can verify that I rise 2 and run 1, which gives me a slope of 2. So my equation seems to check out. The last thing I want to do is I want to verify that my equation actually gives me the values that are here in the table. So let's check when our number of minutes is 2. Let's plug in 2 and see if we actually get 9. So this is just a check to make sure my equation works. I want to know what is the number of gallons when my number of minutes is 2. So I'm substituting 2 for the x and adding 5. So 2 times 2 is 4 plus 5 equals 9. And so that matches what I have in the table. When 2 minutes have gone by, I should have 9 gallons, so I know my equation checks out. So now we have 3 representations. We have our table, our graph, and our equation. And now we're going to use the equation to answer some questions. So our question here is how much water will be in the pool after 1 hour? Now here's what we have to be careful of, because we said that our input was the number of minutes. So the first thing I need to do is I need to take this and change it into 60 minutes. And now I can use my equation. The number of gallons, y, is equal to 2 times the number of minutes, which is 60, plus 5. And if I use my calculator, I would get 2 times 60 is 120, plus 5, so I'd have 125 gallons. Now, the next question is asking me, when should you turn off the hose? Well, I'm going to turn off the hose, and it sounds silly, right? We're going to turn off the hose when the pool is full. I know that's going to happen when the number of gallons which is y, is equal to 1,500, because that's how many gallons my pool is going to hold. So let's go ahead and set up our equation here. So now we know y is equal to 1500 and we want to solve for the time. So I have 1500 equals 2x plus 5, and we're going to solve for our x value. So the first thing I'm going to do is subtract 5. So I'm going to get 1,495 equals 2x. And so we're going to divide by 2. And using our calculators, we're going to get 747.5 minutes. Now, I always like to think about whether a decimal makes sense in the context of my problem. If I have minutes, I can definitely have half a minute. That's just 30 seconds. So I'm going to go ahead and leave my decimal in this problem. Okay, so these are the types of problems that you're going to be working on for the rest of the class period. My one heads up that I will give you is, in this example, we had a positive slope, right? Because the number of gallons in the pool were increasing. Make sure as you go through the practice that you ask yourself, should my slope be positive or negative? What is actually happening in the problem? All right, so thank you for watching along with that. I hope that helps you work through the practice. And obviously, as you're going through, if you have questions, please be sure to check in with Mr. Ho. Thanks. Hope it's a great class.